Hello, everyone. Today we are continuing our triangles, and we now have all our tools to proving triangles congruent. So now we're going to focus on isosceles and equilateral triangles. Definition: an isosceles triangle is a triangle with two congruent sides. So we knew that earlier. Theorem: if two sides of a triangle are congruent, then the angles opposite those sides are congruent. So in my triangle up here, I have it labeled that AB and AC are congruent. So since that's a triangle, that means that angle B is congruent to angle C. Because in an isosceles triangle, the angles across from the congruent sides are always congruent. And here it is again with arrows. Follow up. If two angles in a triangle are congruent, then the sides opposite these angles are congruent. So this is the theorem backwards. So this means if I have this triangle ABC, and I know angle B is congruent to angle C, then AB is congruent to AC. So now let's talk about different words in terms of isosceles triangles. The angle between the congruent sides, up here it would be A, is called the vertex angle. So this is the vertex. Doesn't matter if it's up top or not. It's the one that's in between the two congruent sides. The sides that are equal are called the legs. So this is the leg. This is the leg. The unequal side is called the base. So in my triangle up there, it's BC. The two equal angles are called the base angles. And they're called the base angles because they're along the base. So in my example up there, it's angle B and angle C. So let's see how we can apply this information. In this triangle, so if we look at this triangle, we know that angle R is congruent to angle S because it's labeled. Oh, actually, that's not what it's looking for. Sorry, I need to read the question better. Angle R is going to be congruent to angle UVR because angle in a triangle angles opposite congruent sides are congruent. RT is going to be congruent to TS because in a triangle, sides opposite congruent angles are congruent. And then again, because that one I'm looking at the large triangle, then if I look at the small triangle for VW, this purple triangle, again, I have these two angles are congruent. So that means VS is congruent to VW because in a triangle, sides opposite congruent sides or congruent angles are congruent. You must always say in a triangle. This is only true in a triangle. So now we're going to discuss equilateral triangles. Equilateral triangle, all three sides are congruent. Therefore, in a triangle is equilateral, it is also equiangular. And that follows from the theorem that we know that in a triangle, angles across from congruent sides are congruent. If all three sides are congruent, then all three angles are congruent. And that works also if I know it's equiangular, then it's equilateral. So now how can I find x and y? So if I look at this triangle, I'm going to focus on the bottom one that I'm making purple, which is isosceles. So that means if this angle on the left is 55, this one on the right is 55, which means using that purple triangle, x plus 55 plus 55 equals 180, because the angles in any triangle add to be 180. So that's x plus 110 equals 180. Therefore, x equals 70. Well, since x equals 70, and that's the vertex angle of that triangle, but more importantly for this next step, it's vertical to the vertex of the other triangle, that vertex is also 70. Which means I could do that equation again. You're going to realize that y plus 70 equals 180, but hopefully you realize that that means y is also going to be 55. Now in this problem, I want to find x and y. So I know that this is a right angle down here, and I know that 110 is the exterior angle. So since 110 is the exterior angle, y is going to be 20, because the exterior angle is always the sum of the two remote interior angles. And that means that this angle down here is 90. No, not 90, sorry. Bad arithmetic on my part. 70. And therefore, x is also 70 because it's opposite congruent sides. And hopefully you notice that these two triangles are congruent then as well. Lastly, example 3, I want you to pause and try on your own and come back and check. Okay, so for this problem, we need to remember some stuff from algebra. We have congruent base angles, which means the sides opposite those angles are congruent. So that means x squared plus 4x equals 21. This is a quadratic. To solve a quadratic, it must equal 0. So that means I'm going to subtract 21 from both sides. So I get x squared minus 21 equals 0. And now I want to factor. Remember, when I'm factoring, I'm looking for numbers that multiply to be c, or in this case, negative 21, that add to be b, which in this case is 4. So negative 7 times 3 adds to be negative 4. But 7 times negative 3, those multiply to be negative 21 and add to be 4. Therefore, this is x plus 4, or I'm sorry, not 4, x plus 7 times x minus 3 equals 0. Now that I know the two factors that multiply to be 0, that means one of those has to be 0. So x plus 7 equals 0 and x minus 3 equals 0. Which leaves me with the answers x equals negative 7 and x equals 3. I then must check to see if those work. So when I substitute in negative 7, I get negative 7 squared plus 4 times negative 7, which does equal 21. Doesn't give me a negative value. So that is the solution. 3 squared plus 4 times 3 also equals 21. So they are both solutions. So that's it for today. If you have any questions, please bring them to class on Friday.